Bismillahirrahmanirrahim. Assalamu alaikum, dear student. I do hope you will be in best of your health. In today's lecture, I will brief you about continuous function. If a function is not continuous, then it would be discontinuous, and we will study different type of discontinuity. So first of all, I would like to introduce what is continuous function. A function at a point x is equal to c is said to be continuous if it satisfies the following properties. Fc is defined. Defines means its value exists at point C. When we put the value of C in a function, we get a real number. It means that function is defined. Secondly, limit at that point C exists. Third, uh, value of the limit at point C and the value of function at point C is equal. If a function satisfies these three properties, then function is said to be continuous. If a function does not satisfy one or more axiom uh, from these three properties, then function is said to be discontinuous function. Types of discontinuity. There are three types of discontinuities. First is removable discontinuity. Second is jump discontinuity. And third is infinite discontinuity. Now, I will give you a detail of all three types. First type is removable discontinuity. In a removable discontinuity, the limit of a function at point C and the value of function at C is not equal. That is, third property is not satisfied. The third property is not satisfied, then that discontinuity is termed as removable discontinuity. I will clear it with the help of an example. Consider a function f of x is equal to x square plus x minus 2 divided by x minus 2 if x is not equal to 1, and is function is equal to 2 if x is equal to 1. From this uh, question, we have value of function at x is equal to 1 is 1. Second, we will check the limit x equals to 1 x square plus x minus 2 divided by x minus 1, making the factor of the numerator that will be x minus 1 into x plus 2, and cancelling the uh, factor from x minus 1 from the numerator and denominator, we will have limit x equals to 1 x plus 2, and this is simplified form, and we will put the value of limit and we'll get the value of limit 3. Now function value of function at x is equal to 1 is 1 and the value of limit is equal to 3, and f of 1 is not equal to the value of limit at x is equal to 1. So this is called removable discontinuity. Graphically, uh, this is the graph of the our question. Uh, if we approach the limit x is equal to 1 from right hand side, we get the value function 3. And if we uh, move from the left hand side at x equal to 1, we will get the value of the limit 3. Limit exists, that is shown by open circle, and the value of function at x is equal to 1 is 2. This is the shaded value, and this is not equal to the value of the limit, so this is called removable discontinuity. Uh, and now I summarize this removable discontinuity. The value of the limit exists, but value of function at that point is not equal. So this is called the removable discontinuity. Second type of discontinuity is removable jump discontinuity. I will clear it with the help of an example. Limit x approaches to 0, x mod divided by x. First, I would like to find the left-hand limit at x is equal to 0. Limit x approaches to 0 minus, that shows the, we will approach the limit for values less than 0, x mod divided by x. For uh, I will redefine the value of what is mod x mod. X mod is equal to plus x uh, when x is greater than equal to 0, and this is equal to minus x when x is less than 0. So for left hand limit, we will have the value of the function x mod is equal to minus x, and cancelling the common factor from numerator and denominator, we will get minus 1, and if we put the value of 1, we get left hand limit minus 1. In a similar manner, we will find the right hand limit x approach to 0 plus. It means that we will approach the limit for values greater than 0, and limit x approach to 0 x divided by x, considering the common factor. Limit is limit x approach to 0 1, and will get the right hand limit 1. As the left hand limit is not equal to right hand limit, that will be jump discontinuity. And graphically, if we approach the limit from right hand side, we get the value of 1. If we approach the limit from left hand side, we get the value of minus 1. In jump discontinuity, there is a jump. The right hand limits exist above the left hand limit. This is called the jump discontinuity. Third is the type of discontinuity is infinite discontinuity. As its name suggests that we will get the limit value of the limit infinity. If the one of the value of the limit uh, is infinity, that is type of discontinuity is called infinite discontinuity. I will clear it with the help of an example. Limit x up to 0, 1 divided by x. If we find the limit from left hand side, we get the value of limit minus infinity. If we approach the limit from the right hand side, we get the value of limit is equal to plus infinity. As the limit does not exist, so this type of discontinuity is infinite discontinuity. And graphically, uh, if we approach the limit x is equal to 0 from right hand side, the function becomes infinite, and it means that value of the function exists increases without bound, that is termed as positive infinity. If we approach the limit x is equal to 0 from left hand side, the function decreases without bound, and this is termed as minus infinity. So I have created the concept of discontinuity. It's tried with the help of suitable example. Now solve some question from the exercise. Exercise number 1.5. Question 1 to 10. The graph of a function is f is given. Classify the discontinuities of f as removable, jump, or infinite. This is the graph is given. If we approach the limit x is equal to from left hand side, we get the value of function is equal to 3. If we approach the limit x is equal to 2 from right hand side, we get the value of the function is equal to 1. As the left hand limit is not equal to right hand limit, so this type of discontinuity is called jump discontinuity. I have also told you that the value of left hand and right hand limit uh, occurs uh, above 1, um, above and down. This type is called jump discontinuity. Now let's do some example of other type, that is removable discontinuity. Question number 2. Uh, if we approach the limit from right hand side at x is equal to 2, we get the value of function 4. And if we approach the limit from left hand side at x is equal to 2, we get the value of function 4. And left hand limit is is equal to right hand limit, and limit exists. Now we will find the value of function at x is equal to 2. We see that the value of function at x is equal to is 2. Now, third property is of the continuous function is not satisfied. That is, limit x approaches to f of x is not equal to f of 2. This is the type of discontinuity is called removable discontinuity. Now, we will do another question from third type. Question number 7. Uh, Limit x approaches to minus, it means that we will approach the limit from values less than 2. If we approach the limit uh, x is equal to from left hand side, we see that the function decreases without bound, and it is termed as minus infinity. Now you find the right hand limit. If we approach the limit x is equal to 2 from right hand side, the function increases without bounds, that is termed as positive infinity. As the both left hand limit and right hand side limits approaches to infinity, minus infinity and plus infinity. So this type of discontinuity is called infinite discontinuity. Now solve another question. Now we will solve algebraically the value of the limit, and we will classify the discontinuity as a removable jump or infinite. Question number 11. F of x is equal to x square minus 1 if x is less than 1, and is equal to 4 minus x if x is greater than or equal to 1. Limit x approach to 1 negative of f of x, we mean then we will approach the limit for values less than 1. For less than 1, we have value of the function is equal to x square minus 1. This is in the simplified form, and when we put x is equal to 1, we get the value of the function is equal to 0. This is the value of left hand limit. Now we will find the right hand limit at x is equal to 1. Limit x approach to 1 plus f of x is equal to limit x approach to 1 4 minus, and it's mean that we will approach the limit for values x greater than 1. For x greater than 1, we have value of the function is equal to 4 minus x. This is in the simplified form. We will put the value of x is equal to 1. We will get the value of the limit is equal to 3. As the left hand limit at x equal to 1 is not equal to value of the limit at x is equal to 1 at right hand side, so this type is called jump discontinuity. So dear student, I do hope now you will have a better idea about a continuous function and type of discontinuity. So study this lecture. If you have still question, we will inshallah discuss in our online session. Till then, take care of yourself. Allah Hafiz.